Hello students, this is Mr. Yao. Today we're going to talk about 1.1a, which is called Algebraic Properties. We will learn a lot of definitions of algebraic properties. These may be things you have used before, and they're basically just algebraic facts to you, but you have never thought about what they're actually called, and they all have names. That's what we're going to learn today, a lot of definitions. So first, what is algebra? Algebra is math using letters and symbols. And of course, it's about numbers. That's a given. It's math. So it's of course going to be about numbers. But algebra is also about letters and symbols. And we have two words, algebra and algebraic. Algebra is a noun, and algebraic is an adjective. So for the past few days, we have reviewed solving equations. And you may know how to solve equations, but we may not fully understand the mathematical theories that allow us to take each step when we solve them. So today we'll explore the properties or reason behind each step that we take. And here we go. First view. Additive identity. If you add 0, you get the same thing. Of course, if you, for example, a plus 0, you got a. It just got the same thing. A could be anything like 5 plus 0, that's 5. Or negative 3 plus 0, that's negative 3. You get the same thing. Second one, multiplicative identity. If you multiply by 1, you get the same thing. So this time it's not multiplied by 0, because that would just give us a 0. It's by 1. And you get the same thing back. So b times 1 gives us b. Third one, additive inverse. Inverse means opposite. So if you add the opposite, you get 0. And opposite means if you have a positive number, you add a negative one. If you have a negative number, you add a positive. So 9 and negative 9, negative 8 and 8, they're inverse. And since we add them together, we got a 0. That's called the additive inverse. The fourth one, multiplicative inverse. If you multiply by the reciprocal, you get 1. If you forgot what reciprocal means, we actually did it in review number 1 when we divide by fractions. Let's say we're dividing by 3 over 5. We actually do it as multiply by 5 over 3. And that is the reciprocal when we flip the fractions. Okay, multiplicative inverse. 12 is basically 12 over 1. If I multiply by that by 1 over 12, which is the reciprocal, I would get a 1. For the bottom one, if I actually want to get a 1, I would need the reciprocal. So the reciprocal for 4 over 3 is going to be 3 over 4. And they multiply together to give us a 1. These are the first 4. Please make sure you use the right term. It's not addition and multiplication. It's actually additive and multiplicative. You will also need to be able to tell apart identity and inverse. Identity is when you actually just get the same thing. That's basically what identity means. So here are the first 4. Moving on. 2 more. Commutative property of addition and multiplication. When add or multiply, you can move things around and get the same answer. Commutative come from the words commute, which basically means travel from one place to another. So future your coworker may ask you in the morning, hey, how was your morning commute? That just means how was your drive from your house to work. And commutative here means the same thing, move around. So for example, 2 is on the back. Well, I can move it to the front, so it's the same as 2 plus 1. A times b, I can switch things around. I can move b to the front. That means a times b is the same as b times a. Next, associative property of addition and multiplication. That comes from the word associate or associated. That just means things are together, things are related or connected. So when add or multiply, you can group things differently and get the same answer. So let's see the example. 3, 4, 5, I can group 3 and 4 together, group things together using parentheses in math. I can also group the 4 and 5 together. They will give me the same result. Or when we multiply, I can either put the x and y together inside parentheses and leave a z outside, or I can put the y and z together, leave the x in the front. So that's another 2. Here, to just clarify, for each one of these properties, actually 2 separate properties. One of them is commutative property of addition, and the other is commutative property of multiplication. So that would be the addition one, and this would be the multiplication one. So please be sure to separate them. There is no property called commutative property of addition and multiplication. It has to be two separate ones. Same thing with associative. Moving on, a couple more. Top one, distributive property of multiplication. That's something we have been doing, especially when we solve equations. We just distribute. So when the 7 is outside, we need to distribute it inside. So we got 7x minus 63. And we distribute so that we can get rid of the parentheses. Multiplicative property of 0. When you multiply by 0, you got a 0. So a times 0 gives us a 0. Doesn't matter what a is. It could be any number. It could even be 0. Or just like a super big, super small number. Either way. Next, substitution property. You can plug something in, or you can think it as you can replace something for something else it is equal to. So if I know b and 4 are the same, I can replace the b with a 4. That is substitution property. Next, symmetric property of equality. You can switch the size of an equation and it's still the same. Well, because if I say, like, let's see, I have this product, I have this shape that's actually symmetric, that means the left side and the right side are actually the same. So I can switch them. So left side x, right side 10, I can switch them to be 10 equals x. That still works. And you guys actually use this quite a bit. So for example, you have a question 10 equals 2x plus 4. Well, I can rewrite it as 2x plus 4 equals 10. Well, that's symmetric property of equality. Next to addition property of equality and subtraction property of equality. And these are the most common things you actually use to solve equations. You can add or subtract the same thing to or from both sides, get a new true or equivalent equation. That just means, equivalent just means equal, but logically equal. So here, we have a negative 4, we would add 4. You just need to make sure you also do that same thing on the right side. If you have a plus 5, you would subtract 5. Same thing, you just need to make sure you do it for both sides. Next, if you are dividing by something, you can multiply by 5 on both sides to get rid of it. And that is multiplication property of equality. You can multiply both sides by the same thing and get a new equivalent equation. Or if it's already being multiplied, you can divide both sides by a 4. That would be the division property of equality. You can divide both sides by the same thing and get a new equivalent equation. The only time is you can't multiply by a 0 because we have the multiplication property of 0. That means whatever you multiply, you're going to get a 0. So it's just going to get you 0 equals 0, which, yes, is right, but that doesn't actually help us. Okay, and again, to emphasize, these are two separate things. Addition property of equation, subtraction property of equality, or multiplication property of equality, or division property of equality. Now we have 3 more. Equality property of exponentials. As long as the bases are equal, if you don't remember what bases are, the bigger number on the bottom, that's a base. So these two are the bases, 6 and 6, they are the same. If the bases are equal, then the exponents must also be equal. So we can conclude this x and the 2, that x actually equals to 2. And just to emphasize on that, this is the only property where you can conclude just about the exponent. See, in my conclusion, the 6 is gone. I don't have the 6 anymore. I only have the x and the 2. Please keep that in mind. Next, reflexive property of equality. A real number is always equal to itself. So 12 is 12, a is a. Just to clarify, it's seriously the same number. It's not x equals 2. It's not x equals 2. That does not work. It's just a number is exactly the same thing itself. Next one, transitive property of equality. If two numbers are equal to the same number, then the two numbers are equal to each other. You can see 2a equals 10, but 4b also equals to 10. So 2a and 4b are being connected by the 10. I can conclude 2a equals 4b. That's transitive property of equality. Now that's all the properties. Let's look at a few examples. First one, what property is used in the following statement? If you're just watching this video to learn stuff, please pause it here and try it for yourself. Then you can start it again to actually check your answer. If 6 to the x power equals 36 and 36 equals to 6 to the second power, then 6 to the x power equals 6 to the second power. You might think, oh, I see exponents, so it must be the equality property of exponentials. Unfortunately, it's not. Like I have emphasized on, the equality property of exponentials, you have to just conclude about the exponents. However, in this example, we're not just concluding about the x and the 2, we're concluding about the whole thing, which is why it's not that. But if you look more carefully, 6 to the x power equals 36. 6 squared also equals to 36. So these two things are being connected by 36, which is why this is actually transitive property of equality. Number 2, x equals 5, then 3x equals 15. I'll give you a few seconds for you to think. Now, some of you may think this is substitution. Some of you may think this is symmetric. Or some of you may think this is multiplication property of equality. Well, let me explain. You may think it is substitution because you're like, wait, I know x is 5, so I can actually know 3 times 5 is 15. However, if it's actually substituting, you would need to see that replacement happening. But then you would need to actually see 3 times 5 equals 15. The x is being replaced by the 5. However, that's not happening here, so it's not substitution. And next, maybe you think it's symmetric. Well, the left side is x, the right side is 5, and now it changed. It's not just x and 5 anymore. For symmetric, it would have to be 5 equals x. That would be symmetric, so it's not symmetric. Now, it is multiplication because what actually happened is from here, the x didn't change, but I multiplied by a 3. The right side, the 5 didn't change, I also multiplied that by a 3. That's why it's multiplication property of equality. And here are some short versions you can use. You don't have to spell out property. You can just write it as prop dot. You also don't need to write out property of equality. You can just do it as POE. Just save yourself some time. Now, example 3. In the example, you've got to notice is actually 1 times 487. That 1 is not a question number. It is actually in the statement. So because we have a 1, this basically is 1 times something is itself. This is going to be multiplicative identity because we multiplied by 1 and didn't change, so that's identity. Number 4. You can see the changes. The 4 is being distributed to the x and the y. So that gives me the next step, which is why that's going to be distributive property of multiplication. That's everything for 1.1a. Thank you.